Hello everyone! I've been wanting to make an update for my channel for quite a while, and I want to sort of address an elephant that I've placed in the room for myself. And the thing is that I don't really like to not make a more complete video. For me, who is still very not used to making videos and don't have very good equipment, there is a lot of effort that goes into making any video. And because I don't really want to make unfinished videos, I haven't been finishing any videos and I haven't been uploading anything. And I think that I need to think of this differently. I need to consider that if most of the stuff I do might be interesting to someone, but it's not enough to be a finished thing, then it will never be seen by anyone, and then my goals aren't being met. So for me to meet my goals is to upload more regularly, even if it's not a complete video that covers some topic or some specific project from A to B. And in that spirit, I wanted to talk a little bit about a diamond cutter that I got. And I got it because I'm starting a business, and I will talk at length about that process eventually. But currently, I just wanted to see, can I cut glass in a good way? So I do have a regular little roller with so I do have a regular glass cutter that you can roll on along the glass to make a score and then cut it. But sometimes you want more intricate shapes. And I also want a solution to cut printed circuit boards. And I've been using shears before, but using shears can create issues with the photoresist that it comes off. So when cutting the laminate with the shears, I risk damaging the photoresist because it causes bend strain on the laminate. So one solution to this is to use a ceramic tile cutter. And usually these will have a slow spinning wheel that is also in a bath of water as a cutting fluid. That is also very nice because it mitigates the dust problem. You don't want to inhale glass particles or ceramic tile particles. And the laminates, they're made of fiberglass. So something that can cut glass is likely to be able to cut these laminates well as well. So here is the tile cutter I got. It's one of the very cheapest you could imagine. For one thing, there is some backlash here with the gear. So that's a problem. Another problem is that when it runs, it's very loud. It's something like 98 dB for a meter away or something ridiculous. And that makes it harder for me to actually make use of this machine because I live in an apartment and my hobby space is also under some apartment. So I don't want to be making a horrible mess. And I'm also not super excited about having my face near a cheap thing that spins at 5,000 RPMs. So I would very much like this thing to go much slower. I do like the table itself. I do like this compartment here where you put the water, and the water will mitigate dust issues and makes it much safer to use. So if we can only make this go slower, that's nice. And now we can see the first issue. I'll just hold it still here. This blade is not very straight. And I don't know if it's actually the blade or how it's mounted or if it's the thing it sits in, but I'm going to investigate that a bit closer later on. So let's have a look at the backside here. So this is a very simple setup. We have, okay, so I should show you that these two wires here should go here. And this is a so-called safety switch. And what's safe about it is that when you have turned it on, and if the power goes out, it will automatically turn off. So when the power comes back, you don't have a bunch of things starting up again. So that's very useful. Then here is a little filter capacitor that's connected to ground. The wires here are painfully stretched in a way that I don't really approve of, but I can fix that. And here we have the motor, and it actually has a small reduction gear here. The motor in here is the type of motor that works on both AC or DC. It uses carbon brushes to accomplish this. And it also works on a very wide range of voltages. So it's intended to run on 230 volts. Currently I have 10 volts hooked up to it. And what happens now is, and I don't recommend you to ever touch anything that is connected to anything, but now it's easy for me to move it this way and hard to move it the other way, because there is some bias for it to go this way, but not enough to overcome all the friction and stuff here. But if we increase the voltage a bit, now it starts moving. So when I'm testing this, I'm just inputting power in these two wires that goes here. So let's hook it back up. And again, this works on both AC and DC, so it doesn't matter which way you connect it. And now it's running. Do not put your fingers in here. So now we get to the most interesting thing here, which is, will it actually cut something? Probably not at 16 volts. So currently I'm giving it a very low power. So this means that even if I would never recommend this, you can actually stop it with your finger. But you shouldn't do this, even if this thing here isn't very sharp, because it's mainly made with diamonds, and the way this works is that the metal gets ground away and that exposes the diamonds, and then the diamonds actually cut into piece. So even though it's not super easy to cut yourself on this, there is still a risk, and whenever you have a motor that's powered up, you shouldn't touch the thing that is powered up. But at this low power, it will just stop. But if we increase the power a little bit, now I wouldn't put my finger there. So what I imagine is that maybe if we run it at 20 volts, that's a good value that doesn't that is slow and safe and not too loud, but still can cut glass. So let's try this. We'll have to first fill up this compartment here with some water and hope that it's not leaking. And then we'll get a piece of glass and see what we can do here. Oh, is that an overflow thing? It looks kind of close to it. Yeah, that is an overflow thing. We don't want to overflow it. Better take some out. I don't know if this is a reasonable solution. I couldn't find any big syringes or pumps or anything useful like that on short notice. Well, we got a little bit. Oops. Let's try 24 volts. So let's try to cut this bottle here. So here we have the cut. And this was on 24 volts. So let's try to increase it a little bit and try it on, let's say, 35 volts. Now it's actually squirting water here, and it lands here, and then it flows around here. And it splashes me as well, which is kind of annoying. And we'll try to make a cut different from the first one. Let's see, I want to focus on where the actual cutting action is. I really need to make a click and point autofocus for the new camera, but not today. Not today. So let's see here. Oh, this thing was in the way. Okay, this cost a lot of water to run down. Actually, we have to abort the experiment. So the cut itself looks good. Like, I went through it. Obviously, I need to fix how wobbly it is if I can, but I don't really like the wobbliness. We're going to have a look into that. But the big problem why I have to stop right now is that because this thing is not really properly installed here, the fluid started to drip down on my floor, and I really need to just take care of that and take care of the fluid. But all in all, I think this is a good start, and I'll follow up sometime with investigating the wobbles, if we can fix that, putting things together, maybe just put like an external power connector here so we can run it on from the bench supply, and then in the future, of course, have a dedicated power supply to this thing, so that we can adjust how much power we're inputting it depending on what we are using it for. If we're just cutting laminates, we can probably do it on 20 volts. If we're cutting glass, maybe 36 volts is a better solution. Anyway, thank you for watching, and I'll get back to this project. I'll get back to the laser lithograph, and I'll share a lot of my other stuff in progress type of stuff, and I hope that you will enjoy it. Thanks for watching. Bye bye. Oh, this is confusing. Let's see. Where is focus? Where is camera? What is orientation even? Okay, we need to do the audio synchronization stuff.